So we're going to start with our previous knowledge for it should say chapter 1. That was my bad, so I'll cross that out. This is chapter 1 that we're going to start with. So we're going to talk about a few things that we studied a lot in secondary 4, and that would be solving systems of equations. So remember, a system of equations is a set of two or more equations of a line. So remember, we have a y equals ax plus b. And we could have a general form of ax plus by is equal to c. Two lines. System is two or more lines. There are various strategies used for solving a system made up of two first-degree equations. They are used to find out which values satisfy both. So we are finding the point of intersection. We are finding the point where both lines cross. That is the solution of a system of equations. So there are a couple of strategies that we talked about last year about how to find the point of intersection. The first one's the easiest, graphing. In a graphical representation, the coordinates of an intersection point of two lines is the solution. So here we have 2y equals ax plus b. Remember that the a is the slope and the b is the y-intercept. So if we look here, the 6 is the y-intercept of this line, first line, and it has a negative slope, so it's going down. And then the second line is that it starts at plus 1 and it goes up 1 over 4, so rise of 1 and then over 4. So it's going up like this. And if we look here, the point of intersection, it's really easy to see on a graph. So the point of intersection, so the solution of the system above is 4, 4. And remember, x is first, y is second when you're talking about a coordinate. So that is the solution. That is where both of these lines cross, where they both have the same answer. That's why we call it a solution. The next is a table of values. We don't see this that often in secondary 5. So again, you have two y equals ax plus b's. You have two equations of a line. And it says that the independent variable, which is the x, is alone, so it's right here. And then you have two y's, and it's where the dependent variables are the same, which makes sense, right? Because it's two coordinates that are the same. So the point of intersection for this guy is 1 and 3. So that is the solution for this equation. Now the next strategies are ones that we use a lot when we talk about algebra. So the first one's comparison method, which we also call y equals y. Comparison method is done when two linear equations, remember linear means equation of a line, they are given in y equals ax plus b form. Remember, a is the slope, b is the y-intercept. So we're going to solve the following system, which means that we need to find the x-coordinate and we need to find the y-coordinate. So they're both in y equals ax plus b form, so we make them equal to each other, which is why we say y is equal to y. So 4x minus 2 is equal to 3x plus 4. So as you can see, we're solving for the x variable first. So we need to combine like terms. So we're going to put all the x's together. So because this is a positive 3, we want to move it to the other side of the equal sign, so we have to do the opposite, which is minus. So 3 minus 3 gives me 0. But whatever I do to one side, I have to do to the other side. So 4x minus 3x gives me x minus 2 is equal to 4. Now we want the x to be all by himself. He's not. He has this negative 2 with him, so we need to move that negative 2 over to the other side of the equal sign. Negative 2 plus 2 gives me 0. Whatever I do to one side, I have to do to the other. So x is equal to 4 plus 2, which is 6. So we have our x-coordinate, and we're not done yet. We have the x, it's 6, but we need to find the y. So you pick any equation, it doesn't matter which one, and you will substitute the x in for, or the 6 in for the x. So we'll pick the first one. Y is equal to 4 times 6, that's why I'm putting the bracket there. That bracket means that I'm substituting in for the x. 4 times 6 minus 2. So y is equal to 4 times 6, which is 24, minus 2. So y is equal to 22. So the point of intersection, or the solution for this equation, or for these two equations I should say, is 6 and 22. Now you can check your answer. How do we check our answer? Well, we put both values in. So 22 is equal to, and I'm going to take the second one just to see if it works, 3 times 6 plus 4. 22 is equal to 3 times 6, which is 18, plus 4. 22 is equal to 18 plus 4, which is 22. It works. So we know that this solution works. Always check your answers. There is no reason for you to get these types of questions wrong because you can always check your answers. So that is comparison method. I have another example here which you can try on your own, and I'm going to give you the answer so you can make sure that you try it. So the solution for this one's 14 and 16. So you're going to give this one a shot on your own. So pause the video and give it a shot. Now the next method is substitution method, which some of you, I think last year, found a little bit more tricky. A substitution method is done when one linear equation is in function form, so y equals ax plus b, and the other is in general form. Okay, so we're going to solve it using substitution. So as you can see here, I have a general form and I have a function form. So what substitution means is that you're going to take that y equals, and you're going to circle everything that the y equals. Y equals negative x minus 4. Y equals all of this. So if that's the case, then you can plug it in for the y right there. So 3x plus 2 times negative x minus 4, because y equals all of that, is equal to 5. And would you look? We're solving for x. We got rid of the y for right now. We're only solving for x. You want one variable. So we are going to get rid of our brackets. So 3x minus 2x minus 8 is equal to 5. Now we combine our like terms, so 3x minus 2x gives me x. X minus 8 is equal to 5. Now we want the x all by himself, so we need to move the 8 across the equal sign, which means that we add it to each side. So x is equal to 5 plus 8, which is 13. So that's my x value, but I'm not done. I need to find the y. So you can pick any equation you want, but the easiest one would probably take the function form. So y is equal to negative 13, because we put the bracket there because we're subbing in for x. Negative 13 minus 4. So y is equal to negative 17. So the solution to my system of equations is x first and y second, so 13 and negative 17, and we can check our answer. So let's take the general form and substitute our values in. So 3 times 13, because that's the x value, plus 2 times negative 17 should equal to 5. And if you put that in your calculator, it should work. So 3 times 13 is 39. Plus 2 times negative 17. Now remember, if you're putting it in your calculator, you put the negative 17 in brackets. Negative 17 gives me negative 34, and it should give me 5, and that's the right answer. 39 minus 34 gives me 5, so this works. So you know that that is the right solution. Now, the next one, I have another one here at the bottom, another example, and I'm going to give you the answer to the solution. The answer to the solution is 3 and 1. So I want you, the answer, to the system is 3 and 1. So you're going to pause the video and you're going to try this one on your own. Go for it. So the last strategy that is used the most common in word problems is elimination method. Elimination method is done when both linear equations are in general form. Okay, so ax plus by plus c is equal to 0, or ax plus by is equal to c. Both are in general form. So here we have our general form. We have two general form equations. Label the first equation number 1 and the second equation number 2. We want to always keep them in order. With that being said, I want you to look. Which one do we want to get rid of first? Do we want to get rid of the x or the y? It'll probably be easier to get rid of the y because we don't need to do much to the y. If we look at the first equation and the second equation, we have 7y and y. What is the common factor between both of them? Well, the common factor is 7. Do I need to do anything to the y on the first equation to make it equal to 7? No. But what do I need to do to the second one? I need to multiply everything by 7, because you have to make, if you're going to eliminate a variable, you have to make them equal. So if I do that, I'm going to rewrite my first one as number 1, because that's what I told you guys we need to do. We always have to keep our work orderly. So 7 times negative 4, 7 times negative 4 is negative 28. Now when we say we have to multiply y by 7, we have to multiply everything in the equation by 7. So 7 times y gives me positive 7y, and 7 times negative 6 gives me negative 42. So the 7's are equal. They're both positive. So how can I eliminate those y's? Am I going to add or am I going to subtract? Well, because they're both positive, I'm going to subtract. But if I'm subtracting, I need to do it for every single part of the equation. So negative 3x minus negative 28 is going to give me an answer of 25x. 7 minus 7 gives me 0. 8 minus negative 42 gives me an answer of 50. So there's where the elimination of the elimination method comes in. You got rid of one of the variables. Now you're solving for the other one. We're solving for x. I want 1x, not 25 of them, so I need to divide by 25. And what I do to one side, I have to do to both. So x is going to be equal to 2. I've solved the first one. Now I need to work on the second one. I need to find the y. Pick any equation. I'll pick the first one. So negative 3 times 2 plus 7y is equal to 8. So negative 3 times 2 gives me negative 6 plus 7y is equal to 8. We want the y to be all by himself, so we need to move that 6 to the other side. 7y is equal to 14. We only want one y, so we need to divide each side by 7. Y is equal to 2. So the solution to my system of equations is 2 and 2, and we can check our answer. I'm going to check it using the second equation. Negative 4 times 2 plus 2 is equal to negative 6. Negative 4 times 2 is negative 8. Plus 2 gives me negative 6. Negative 8 plus 2 is negative 6. So it works, and you can always check your answer. So I want you guys to give the second elimination example a try. The solution is negative 2 and 3. So pause the video and give this one a shot on your own. Now, the last part of the video for review is our word problems. Now, we did a lot of these last year, but I understand if some of you are rusty, so that's why we're going to do one together and you're going to do one on your own. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended? Remember, the first thing that you need to do in a word problem is you identify your variables. So we're going to say let A equal number of adults, because that's what we care about. We want to know how many adults and how many children were left. And let C equal number of children. That's 2 marks right there. You got to identify your variables. Always, 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 always. So, a system, there's going to be 2 equations in this question. So we have 2 things that are talked about here. We have money, so admission for adults, and we have people. So the first one we're going to tackle is money. It's $1.50 per kid. Do we know how many kids? No. So we're going to put a C next to the $1.50. We're going to add that. When we add that together with the $4 for adults, we get a total of $5,550. That's the money equation. Okay, so you keep the money all together. The next one is the number of people. Do we know how many children went into the fair? No. Do we know how many adults? No, but we do know that there was a total of 2,200 people. Oh, would you look at that? I have 2 general form equations. Hooray. You can also, if you want, move it around and use substitution, but for us we'll use elimination. So we use elimination method because we have 2 general forms. So what do we want to get rid of? Well, let's get rid of the A. Just easier that way. So 1.5 4C plus 4A is equal to 50/50. And what do I have to do to the A to make it 4? Because remember, if I want to get rid of the A, I have to make them equal to each other. Well, I'm going to multiply the entire equation by 4. So if I do that, I get 4C plus 4A is equal to 2,200 times 4, which is 8,800. I want to get rid of those positives. If I have positive 4 and positive 4, I have to subtract to make it 0. So 1.5 minus 4 gives me an answer of negative 2.5C. 4 minus 4 is 0. And 5,050 minus 8,800 gives me negative 3,750. I want 1C, so I'm going to divide each side by negative 2.5, because negative divided by negative is a positive. So negative 3,750 divided by negative 2.5 gives me an answer of C is equal to 1,500. Now what is C equal to? Number of children. There are 1,500 children that were admitted to that fair. Now let's find out how many adults were admitted. Well, that's pretty easy. You can say number of adults is equal to 2,200, because that's how many people there were at the fair, minus 1,500. So 2,200 minus 1,500 gives me an answer of 700 adults. So the solution to my equation is there were 700 adults and there were 1,500 kids admitted to this fair. And just to check and make sure that the money checks out, there were 1,500 kids that cost $1.50 each. Add that to 700 adults that cost $4 each. You should get an answer of 5,050. So this works. So the next question, the next word problem, you guys are going to try on your own about a landscaping company. And I'm going to tell you the answer, and you're going to try it on your own. Do not forget to identify your variables and keep your work organized. So the answer is $23 per bush and $47 per tree. So I want you guys to pause the video and try this out on your own. And we will talk tomorrow.